In this video, we are going to look at real numbers and the real line. So far, we have seen natural numbers, integers, rational numbers, and even a few examples of irrational numbers, numbers that cannot be expressed as the ratio of two integers. So now we have arrived at real numbers, and I'm not going to precisely construct a set of real numbers for you. All I want you to remember is that every real number x can be expressed in the following way. This is called the decimal expansion. So it has an integer part, m, so that is an integer, followed by its fractional part, that is x, this is fractional part, which follows the decimal point, and it's made up of the sequence of digits A1, A2, A3, and so on. And these digits are, of course, can take integer values from 0 to 9. Okay, so, and you might remember that rational numbers, fractions, have the property that their decimal expansion either stops at some point, meaning that from some digit on you only have zeros, or it has an infinitely repeating sequence of digits. Irrational numbers, on the other hand, has no such property. So, for example, root 2 has no infinitely repeating digits. The digits just keep going on without having this infinite repetition. Okay, so let me just tell you next that with considering all of these decimal expansions, we can fill up the entire number line. So this way we can represent the set of real numbers by points on a line. We could pick a point for 0, then pick a point for the number 1, and from that point on we can just shift this by 1 units of distance to the left to fill up, to get the negative integers, or go the other, go to the right, the other direction, and get the positive integers. And of course we can subdivide these segments. So for example, here we would have 2/5, which is 0.4. Let's just say it's over there somewhere. Then, for example, we would have negative 4/3, which is negative minus 1.3, with 3 infinitely repeating. Other numbers would include in here the square root of 2, which has the decimal expansion of 1.414, and so on. An interesting number is E, Euler's number. It has the decimal expansion of 2.718, and so on. We will see this number later on appearing in the module. And just to have a big celebrity, pi over there is 3.141, and so on, with infinitely many digits. So with this we have the full set of real numbers represented by points on a real line. And to finish off, I would like you to answer the following question, and you can pause the video and look at the problem below, which asks you to basically compare the numbers root 3 and 1.5. So basically what I'm asking is you to decide whether the square root of 3 is less than 1.5, or is it maybe greater than 1.5, or who knows, maybe they are equal. So my question is to decide which of these 3 possibilities is the actual correct inequality. Okay, so I hope you paused the video and found that it's option B, which is true, because for example, you don't have to know the square root of 3, its decimal expansion. You can just basically square both sides and see that 3 is greater than 2.25, which is the square, which is 1.5 squared. So options A and C are false, and option B is the correct one. Okay, so we have filled the number line with numbers, and you might ask, are there any more numbers? And the answer is yes, and this is what we'll see in the next video when we'll step outside of the real line. I'll see you in the next one.